Okay, moving on to the next geometry problem here. So, like a lot of problems here ask us to get the ratio of something to something. So I think I need to cover that a little bit. The ratio, whenever we are asked to get a ratio, then we all we need to understand is this simple thing here. The ratio of A to B is just A over B, right? So this is what you need to know. So for example, for problem 24, we want to know the area. So our A is the area of the cross section, which is EJCI, and we want to know the area of one of the faces of the cube. So we can just pick any side, any face of the cube. So it could just be F, G, C, B, right? So now it also says let R be the ratio. So this amount is R. So now all we need to do is to get the area of EJCI. But here, what's not given is the length. None of length, no length is given in this problem here. So let me just redraw all that here. So we have a cube, and then we got the midpoint here, and then we have another midpoint here. The, the important information is that it is a midpoint, and now we're connecting it like this, and then connecting it up here and down here, right? So let's put this as x. Then we know that this is 2x, right? Since this is the midpoint. Now, by using the Pythagorean theorem, then we can get the length of this, right? So x and 2x, so a squared plus b squared is c squared, right? Now our x is, now a is x and 2x, and now this is what we want to get. Now, for example, let's put this as L, and this is L, right? So the area of this, as you see, this is also square. Why? Because this length here and length here and length here and length here, all four sides, lengths of all the four or all four sides are the same with each other. Therefore, this is also L. Now, what you get out of this is the area of EJCI, right? So the area of EJCI is, then if you just simply calculate that, this is the same as 5x squared. So it's 5x squared. And now, what is the area of uh, just one of the sides? Then this is x, right? So the area of one of the sides is 2x times 2x. Therefore, that is 4x squared, right? Which is the area of FGCB. All the areas of, each side, they are the same because we are dealing with a cube. So we have 4x squared. So when length is not given, right, we can just put that as a variable, and then we can still solve it because this simply is a ratio problem. So now our R is calculated as 5 over 4, but what we're looking for here is R squared. Therefore, R squared is 25 over 16. Okay, now that's it for this. And then 23, this problem you need to know combination. So I will cover that as my last problem for you. And the next problem here that I want to cover is 15. Okay, let me just check the time. It's not 5 minutes yet. So 15. In the diagram below, a diameter of each of the two smaller circles is the radius of the larger circle. If two smaller circles have a combined area of 1 square unit, then what is the area of the shaded region in square units, right? So now we have a circle here. And now we have two smaller circles. Oh my God. I mean, freehand drawing is so hard. So okay. So this is a center. Now you have a circle here, and then you have another circle here. Okay, I mean, it doesn't really look like a circle at all, but you got the point. I mean, the perfect drawing is on the left hand side, so you can refer to that if you do not see what's going on here. So now what is given is that a combined area of two smaller circles, right? This smaller circle here, I mean, I'm just going to mark them in yellow. Then this is 1 square unit. It says 1 square unit, right? The combined area of these two yellow circles. Now, then, since we do not know like a radius at all, so we wanted to start by putting this as r, right? And you know that the area of a circle is pi r squared. And now 1 square unit is the same as 2 pi r squared, because pi r squared is the same as the length of the area of a smaller circle. Now, automatically, since this is r, and this whole thing becomes 2r. And now we can get the area of the big circle, then that is going to be 2r squared times pi, right? This is the area of the big circle, and this is 4 pi r squared, right? So this is the area of the big circle, right? Now, what do we need to do to figure out the area of the big circle? Now, as you see, this is 1 square unit, 2 pi r squared is 1 square unit. Then you figure this out as 2 square unit, right? You just multiply this by 2 to get this, right? Now, we want to know what is the area of the shaded region. So all we need to do is to subtract two smaller circles from the big circle. So which is going to be then 2 minus 1. Therefore, the answer is just 1. Okay, so that's it for 15. Okay. Now, I think this geometry problem you see, number 4, is too easy to do. And yeah, I think I solved pretty much all the geometry problems for you. And yeah, make sure to watch it and rewatch it if you want. And I will come back to you tomorrow with some algebra, like basic algebra problems. But I'm not going to solve problems that are not that challenging. Okay? Alright. Bye.